Day 17, Radical Expressions and Rational Exponents. Today you will rewrite radical expressions by using rational exponents. You will simplify and evaluate radical expressions and expressions containing rational exponents. Please remember that the nth root of a real number, we always place the root as the index. So you notice your index is your n. So a radical sign that shows no index is what represents a square root, and remember that is an invisible 2. All the properties of square roots apply to nth roots. To simplify radicals, you need to use a factor tree. For square roots, pull out pairs. For cube roots, pull out sets of 3. Fourth roots, pull out sets of 4, and so on. For variables, you divide the power by the index, and whatever you have left over stays underneath the radical. So let's take a look at example A. So we want to make a factor tree for 64. So 8 times 8 is 64. 2, circle at its prime. 4 is not prime. Keep going. So after you come up with the complete prime factorization of what's underneath your radical, you can write it out. 2 times 2 times 2 times 2 times 2 times 2. So for the cubed root, we need 3 of every number that match. So we have 1, 2, 3 2s, so we can bring 1 to the outside. We have 3 more 2s, so we can bring another 1 to the outside. Everything you bring to the outside of your radical, you multiply together. Anything that's left underneath, you multiply together. To simplify your x to the 12th, you divide 12 by 3, and you get 4. So x to the 4th, you would put on the outside of your radical. So 2 times 2 is 4. So this simplifies to 4x to the 4th. So the fourth root of 64, our prime factorization of 64, remember, is 2 times 2 times 2 times 2 times 2. We had 6 2's. We're going to do 12 divided by 4, which gives us 3. So technically we have 4x to the thirds So then to simplify and take out what we have 4 of, we can bring out a 2. We can bring out an x cubed. Whatever's left underneath, multiply back together. So we have 2x cubed times the fourth root of 4. So again, remember 64 was 2 times 2 times 2 times 2 times 2. 12 divided by 5 does not go evenly. So we can take 2 out. So if we have x squared, 2, 4, 6, 8, 10, 11, 2, 4, 6, 8, 10, 12. We want to look to see what we have 5 of that matches. So 1, this is the fifth root. Don't forget your index. 1, 2, 3, 4, 5. You can pull a 2 out. 1, 2, 3, 4, 5. We can pull an x squared out. So we have 2x squared times the fifth root. We have a 2 left underneath, and we have an x squared left underneath of 2x squared. Looking at the last one, if we multiply two radicals that have the same index, we multiply what's underneath them together, so sometimes this helps us simplify. -8, the cubed root of -8, add your exponents, x to the 9th. Well, the cubed root of negative 8 is negative 2. The cubed root of x to the 9th is x cubed, and you've simplified this. Remember, when an expression contains a radical in the denominator, you must rationalize that denominator. To do so, rewrite the expression so that the denominator contains no radicals. So in this example, we first want to separate this to the cubed root of x cubed over the cubed root of 4. I can simplify my numerator because I know the cubed root of x cubed is x, and then the cubed root of 4, I'm not allowed to have a radical in my denominator, so I want to pay attention to what my index is. So I need 3 things that match. So these are, and whatever you do to the bottom, you have to do to the top. So the cubed root of 4 times the cubed root of 4 times the cubed root of 4 is just 4. And then x times the cubed root of 16. We can use our factor tree to simplify 16. 4 times 4, 2 times 2 times 2 times 2. We can pull 1, 2 to the outside, so we have 2x times the cubed root. We leave 1, 2 underneath because we didn't have enough, all over 4, and we can simplify one step further by reducing 2/4 to 1/2. So we get x times the cubed root of 2 all over 2. When we look at the cubed root of 27x to the 9th over y, we can rewrite that as the cubed root of 27x to the 9th over the cubed root of y. I want to simplify my numerator as much as I can in the beginning. So the cubed root of 27 is 3. The cubed root of x to the 9th is x cubed. Then I need to multiply my denominator by the cubed root of y and the cubed root of y because I need 3 things that match. Whatever we do to the bottom, we need to do to the top. Cubed root of y times the cubed root of y becomes the cubed root of y squared. All over y, there's nothing we can simplify, so we're finished. A rational exponent is an exponent that can be expressed as a fraction, m over n, where m and n are negative integers. So we can rewrite radical expressions using exponents and rewrite exponents using radical expressions. The denominator is always your index. The numerator is always your power, and your power can go underneath your radical or outside your radical depending upon what helps you simplify the easiest. So looking at example 3, it says write each radical in radical form and simplify. So our denominator becomes our index, so we are looking at the 5th root of negative 32. I can probably simplify the 5th root of negative 32, making a factor tree, and then I'm going to cube that. So I know that negative 2 times negative 2 times negative 2 times negative 2 is equal to negative 32. Then when I cube negative 32, I get negative 8. If you didn't know that negative 2 was the 5th root of negative 32, you could have easily made a factor tree to determine that. Again, let's look at b, 4 to the 5/2 power. My index is my denominator, which is a 2. The square root of 4, I know what that is, so I'm going to put my numerator on the outside as my power. Square root of 4 is 2. 2 to the 5th power is 32. Write each expression using a rational exponent, so here we're going the opposite direction. Whatever's on the outside is going to be in your denominator. Your power is your numerator. Whatever your base is remains your base. 13 to the 1/2 power. And we are simplified. If you have an invisible number outside your radical, remember it's a 2 because it's a square root raised to the 1st power. So we have 5 to the 1/2 power. Rational exponents, please review your properties of exponents if you do not have them memorized. You're going to use your property of exponents to simplify each numerical expression. Looking at example 1, if we have a power times a power, we add our exponents. So to add fractions, you need to make sure that your denominators are alike. 7 plus 11 gives us 18 ninths. 18 over 9 reduces to 2, and 7 squared is 49. When we have the quotient property, we subtract our exponents. Again, to subtract our exponents, we need to have a common denominator. So in order to change this 2 into a 4, I'm multiplying by 2. So this becomes 6/4. I now subtract 6/4 minus 5/4. Gives me 1/4. I leave it wherever my larger exponent was. So I have 16 to the 1/4 power, which is the 4th root of 16, which I can simplify even further to 2. So remember, you need 4 numbers that match in order to simplify, and 2 times 2 times 2 times 2 is 16. Power to a power, you multiply. So 64, when you multiply fractions, you multiply straight across. 1 times 1 is 1, 2 times 3 is 6. To simplify a negative exponent, you move it to the denominator, so we have 1 over 64 to the 1/6 power. The 6th root of 64 is 2, so we have 1/2 as our final solution. When we have a fraction raised to a power, you need to distribute your exponent to both using multiplication, so we have 8 to the 2/6 over 9 to the 6/12. 2/6 reduces to 1/3. 6/12 reduces to 1/2. The cubed root of 8 is 2. The square root of 9 is 3, and we are finished with 2/3. When you have a negative exponent, you will flip everything underneath or inside your parenthesis, and it will become a positive exponent. Then you just distribute like we did in the previous problem. So you have 27 to the 2/6 over 16 to the 1/4. The cubed root of 27 is equal to 3. The 4th root of 16 is equal to 2, so our answer is 3/2. When we have variables involved, we just want to leave them as fractional exponents. First thing you want to do is rewrite your radicals. So we have the square root, the cubed root of a can be written as a to the 1/3, b to the 1/4. Distribute your power to everything. So a to the 3/6, b to the 3/8. We can reduce 3/6 to 1/2, but then we can't take this any further, so we leave our problem. And you now can complete your worksheet.